Okay, so let's see how this formula works for cos of A plus B. So this is our first compound angle formula. Compound means to put two things together. So compounding angle A and angle B, and this formula gives us this. So we cannot distribute the cos in here, so cos A plus cos B. We actually get this formula though, that's not too bad, okay? It's not as nice as being able to distribute in, but at least we have something that we can break up this angle into, okay? So if we wanted to do, let's say as an example, cos of 30 degrees plus 45 degrees. Sorry. Okay, so we want to do that. Well, that actually equals cos of 75 degrees. Okay, so if we want to find out what cos of 75 degrees is in an exact value, we could break it up into two angles where we know the cos and sine of these as exact values, okay, from our special triangles. So cos of 75, we can now maybe get an exact value for that. So using this formula, we're going to do, so angle A is 30 and B is 45. So cos 30 degrees, cos 45 degrees, okay, minus sine 30 degrees, sine 45 degrees, okay? And from our special triangle, we know what cos of 45 degrees and sine of 45 degrees is. That's from our 1, 1, root 2 triangle, okay? So there's 1, 1, root 2. So we know cos of 45, so there's 45 in there, okay? Cos of 45 is 1 over root 2. Sine of 45 is 1 over root 2, the same thing. And then from our 30, 60, 90 triangle, okay, so if that's 60 in there, that's 30, okay? So this is gonna be 1, 2, root 3. So we can figure out the rest of it. So cos of 30, cos is adjacent over hypotenuse, so root 3 over 2. Okay. Cos of 45 is 1 over root 2. Okay, and then sine of 30, right here, sine 30 is opposite over hypotenuse, so 1 over 2. And sine 45 is 1 over root 2. Okay, so we have a common denominator here of 2 root 2. So we just bring the top together, so root 3 minus 1 over 2 root 2. Now if you want to rationalize the denominator, you can multiply top and bottom by root 2, and you end up getting root 6 minus root 2 over 4, okay? Okay, so that's an example of how the cos of A plus B formula might work. So now we have an exact value of cos of 75. Cos of 75 degrees equals exactly root 6 minus root 2 all over 4, okay? Not as nice as the cos 30 or sine 30 degrees, but it's an exact value. Okay, so we're gonna do more here now. All right, so let's look at cos of A minus B. So cos of A minus B, do we have a formula for this? Well, we can just break it up into cos of A plus negative B, and we can use our cos of A plus B formula. Okay, so our cos of A plus B formula, just as a reminder, is right here, cos A cos B minus sine A sine B. But instead of B now, we're going to put in negative B, because that's what we have here. Okay, so we're going to slide this down. So cos A cos negative B minus sine A sine negative B. Now, because cos is an even function, cos of negative b is going to equal cos of b. And sine is an odd function, so sine of negative b is going to be negative sine of b. Okay? So we change cos of negative b to cos of b, sine of negative b to negative sine b because of even and odd functions. Okay? And now we have the cos of a minus b formula, which is cos a cos b plus, okay, because the negative comes out here, so plus sine a sine b. So when it was plus the angles, you had a minus in here. Now at subtract, you have a plus. Okay, so that's the only difference. Okay, so an example for this one, well, let's do cos of 15 degrees. Cos of 15 degrees, well, we can break that up in two of our special angles, 45 minus 30. Okay, so just to break it up randomly to like 40 minus 35 doesn't really make sense. Okay, well, it wouldn't give you 15, but just random angles you got to pick angles that you know exact values from. Okay, so you've got 45 and 30 are part of our group of exact angles, like 60 and 90 and 120 and all that. Okay, so we use this formula. So cos of 45, cos 30, and sine 45, sine 30 with a plus in between. And we know that we know what the coses and the sines are of these, so we fill those in. Cos 45, sine 45 are 1 over root 2. Cos 30 is root 3 over 2. Sine 30 is 1 over 2. And we get that, and then we can rationalize the denominator. Okay? Now, we want the sine formula, so compound angle formula for sine. Well, if you recall, sine of theta equals cos of theta minus 90. Okay? So we can write sine in terms of a horizontal translation or phase shift of cos. Okay? So there is cos. That's the cos function there. If I just go back 90, and I move that, slide that forward, I have the sine function. Okay? So if I slide that cos function forward 90 degrees, I have the sine function. So I can write sine in terms of cos. So sine of a plus b, well, I'm replacing theta with a plus b. Because I can just put a minus 90 in here, so equals cos of that minus 90, just that, but I'm replacing theta with a plus b. Now I'm just going to move the b around. So these brackets don't really mean anything once they're in here. You can move things around. Okay, so I'm just going to put the brackets with the b minus 90. Now I'm going to use my cos formula for cos of a plus something. This is now the something. And if you remember, there's a minus in it, so it's cos, cos, sine, sine with a minus between. Okay, cos of a, cos of b minus 90, minus sine of a, sine of b minus 90. Cos of a, sine of a stay the same. Cos of b minus 90 is just a translation of the sine function. Okay, so that equals sine. We just talked about that up here. Okay, so something minus 90 equals a sine function. And sine of b minus 90, well, that's moving the sine function forward. So if I take this sine function, I move it forward 90, well, there's 90 there, so it's going to come back here. 90 as negative 90 is here. All right, so if I move that forward 90 degrees, I'm going to end up with a negative cos. So I'm replacing sine of b minus 90 with negative cos b. And that minus then can come out here. And we've got now a formula for sine of a plus b. Okay. So there's sine of a plus b. And now we've got an example to do. Okay, so sine of 105 degrees. Well, 105 can be broken up into 60 and 45. Okay, two of our special angles. And now we can just sub that into this formula here. Cos 60, sine 45, plus sine 60, cos 45. We fill in what they are because of special triangles, simplify it, and we've got an exact value now for sine of 105 degrees. Okay, and 105 was not one of our special angles, but it's two of the special angles put together. Okay, now we can now get the sine of a minus b formula. Same way we got the cos of a minus b formula. Change the minus b to plus a negative b and fill it into the sine of a plus b formula. Okay, so this is what we got. Put in the sine minus b, cos minus b, odd function, even function, so it stays the same. Okay, then there's a minus up front. We might as well just swap these around and put that one second so that we get the sine of a minus b formula. Okay, so this is a compound angle formula for sine of a minus b. Now we got 4 formulas that you really need to try and remember and have a way of trying to remember them. Okay, here's an example. So sine of 15 degrees is 60 minus 45. Okay, I could have done 45 minus 30. There's 2 different ways of doing this. Okay, and we've got plugging into the formula, the same answers again, and we've got root 6 minus root 2 over 4 as sine of 15 degrees. Okay, now, and that's it for the compound angle formulas. The next video we're going to look at do it using radians with it.